Hey, so this is one of my favorite things to do with systems is choosing the best one, the best tool to solve a given system, okay? You have three different ways to solve. You can solve by graphing, you can solve by substitution, oops, I spelled that wrong, sorry. Hold on, that ends so bad. Substitution or elimination. Okay, so we've spent a good chunk of time on each of these three. Each of the three has their merits, and you want to be good at all three because it depends on what the system looks like, which one of these tools you're going to use. Okay, so let's take a look at when you would use each one. So when might I want to graph? I would graph if I had something that was already in graphable form. So if I'm just take a look at these first four, okay, let me see if I can zoom in a little bit. Trying to get all four on the screen at once. Okay, if I'm just looking at the first four, I would not do number one by graphing. Why? Because it's not necessarily set up for me to graph. You could graph by intercepts, but I'm already seeing I'd have one of my intercepts would be 12. I'm not going to do it. Same thing with number two. Same thing with number four. The one that I like is three. Take a look at three. Wouldn't it be so quick and easy to solve that one by graphing? Right? I think it would be. I can very easily plot those, graph them, find my intersection point. Okay, so this one, oh, whoop, whoop, whoop. This one I'll just put a G because I'm going to do that one by graphing. Okay, so now let's take a look at the next one on my list is substitution. So when would I want to do substitution? Substitution is best to do when I have either a variable that's already all by itself on one side of the equal sign, so it doesn't matter which variable, it doesn't matter which equation. So if I have a variable already all by itself, so I do have that in number three, but I already decided I'm going to do that one by graphing. So I'm looking at 1, 2, and 4. None of those have a variable all by itself. Oh, hang on, my screen just went crazy. There we go. So none of them have a variable all by themselves already. So I might think, okay, well, would it be really easy to get one of the variables all by itself? And the answer is yes. So if I take a look at just number one, I'm seeing right here, if I just add 2x to the other side, I'll have y by itself. And then I can go ahead and solve by substitution because I'll have the variable isolated. So I don't think substitution is a bad idea for that one. Okay, if I'm looking at number 4, I'm actually thinking the same thing because it'd be really easy for me to just minus this 4x right here to the other side and get y by itself. So I'd probably do that one by substitution also. You don't have to. I mean, it's your choice because I do see it would be relatively easy to do that one by elimination also. If I just multiplied the bottom by a positive 4, right? I'd get that pair of opposites that I'm looking for. So this one, maybe I'd say either one. I guess the same thing with number 1. You could do whichever one you like better because they're pretty well set up to do either, okay? But number 2, that's one for sure. I would not graph that one, and I would also not do substitution on that one. Not that it would be that difficult, but I noticed right away, look, I have a pair of opposites. That one is screaming elimination. Okay, that would definitely be our easiest one for that. Okay, so now let's go ahead and actually do these out because you don't want to just, now we know what tools are going to be best. Now I actually want to do it. So let's zoom in. On number 1, we said we were going to try substitution on this one. So I would probably go ahead and start by adding 2x to both sides. So actually, you know what, let me undo that. I don't really have enough room. I'll just rewrite it. Okay, so the original looks like negative 2x plus y equals 12. So I'm going to add 2x to both sides. Remember, when you're doing substitution, it doesn't matter if you write it as 12 plus 2x or 2x plus 12. Doesn't matter. But now I have that variable by itself. So the next thing I'm going to do is I'm going to take everything that y is equal to, and I'm going to pop it into the other equation that I haven't touched yet. So I haven't touched the bottom one yet. So in place of that y, I'm going to put everything that y is equal to. So this one will look like 4x minus 4 times everything that y is, 12 plus 2x equals negative 16. Okay, and now I have x all by itself. I can go ahead and solve. 4 times 12 is going to be a negative 48 minus 8x equals negative 16. I'm going to go ahead and combine like terms. So it's a negative 4x minus 48 equals negative 16. Add 48 to both sides. So that's going to get me a positive 32. Divide both sides by a negative 4, and it looks like 8 is going to end up being, I'm sorry, x is going to end up being negative 8. Okay, once you have one of your variables, remember you go right back to that box and plug it in. So now I can figure out what y is equal to. So y is just equal to 12 plus 2 times x, which is negative 8. Oops, running out of room right there. So 2 times negative 8 is going to be a negative 16. 12 minus 16 is a negative 4. Okay, so now I have my answer. Don't forget to put it as an ordered pair, x comma y. There it is. Okay, great. So now the next one, we're going to slide over, and we said this one for sure we would do elimination because I already have that pair of opposites with the x's. They're already set to go. 9y plus 3y is 12y. Negative 27 and 15 is going to leave me at a negative 12. Divide both sides by 12. I get negative 1. Now I can go back to one of the originals. Remember, for the originals, it's the whole thing. I know I crossed stuff out, but you go back to one of your originals. I'll actually pick this one. 6x plus 3 times negative 1 is my y value, equals 15. And I can go ahead and solve for x. 6x minus 3 equals 15. Add the 3. 6x equals 18. So divide both sides by 6. Looks like x is going to be 3. Okay, so now I have my ordered pair, 3 comma negative 1. Awesome. Okay, next up, we decided to do this one by graphing. And if you notice at the end of this document, let's see if I can get there. Yes, here we go. So on the second page of this, I gave you just some grids. These are not problems for you to do out. It's just a space for you to go to actually draw your graphs for whichever of these numbers 1 through 10 you wanted to graph. Okay, so we know we're going to graph number 3. So I'm just going to slide to that next graph and go ahead and graph it. So it was, I'm just going to jot down the equations so I don't have to keep flipping back and forth. So y equals 8x plus 4 and y equals x minus 3. Okay, so let's go to one of our grids. And I will jot them down here below just so we have them right in front of us. Y equals 8x plus 4 was one of them. And then the other one was y equals x minus 3. Okay, so to solve these by graphing, you guys probably already remember what to do. So for the blue one, I'm going to start at positive 4. And then my slope is 8. So normally I'd go up 8 over 1, but I definitely can't do that on this grid because I'm already out of room. So I'm going to go down 8 to the left 1. Okay, so there's that one. See if I can connect these two. Not too good. Let's see if I can move this one down here. That's why I worry about using the line tool. I can't always get them. Just gonna erase it and try it again. Can't always get them just right. Ooh, that's much better. Okay, so there's that one. And now let's switch to red and we'll graph the bottom one. So that one's gonna start at a negative 3. And then it has a slope of 1. So I'm gonna go up 1 over 1, up 1 over 1, up 1 over 1. And if you notice, if I were to go left on the left-hand side, I would have gone down 1 and back 1. So right there is my intersection point. Okay, that one's a little, that one's not very good either. Hold on. I can do it. That's better. Okay, good. All right, so this ordered pair is going to be at a negative 1, comma, negative 4. Okay, oh, and you know what? While you're doing this, if you could tell me what number you're graphing back here, that's actually going to be really important. Otherwise, I'm not going to have any idea which one it is. Okay, so there is number 3. We got that one. Oop. Okay, and now let's go back to number 4. Here it is. And this one, I think we said we could do either elimination or substitution. It's your call. I like elimination better, to be honest, so I'll do that. And I noticed that with the x's, it'd be pretty easy to get those to match if I just multiplied the bottom equation by a positive 4. So let's go ahead and do that. Okay, so I will put that over here. So the top equation, I'm just going to leave it as it is, 4x plus y equals 22. And then my bottom equation, I have to multiply that 4 all the way through. So first I'm going to get a negative 4x plus 32y equals 4 times negative 22 is going to be a negative 88. That's a weird looking 88. There we go. All right, so switch colors real quick. My x's cancel. Y plus 32y is going to get me 33y, right? And then 22 and negative 88 is now a negative 66. Okay, divide by 33. Negative 66 divided by a positive 33 is a negative 2. Okay, so now I have one of my variables. Let's go back to an original 4x, and now I know what y is. It's negative 2 equals 22. So now I should be able to solve for x. So we'll just add 2 to both sides. 4x equals 24. So divide by 4. And what do you know? We got a 6. So my final answer is going to be 6, comma, negative 2. Okay, so this gives you a little bit of wiggle room. You can do whatever method makes most sense to you. I would not, I know some of you are like, oh, I like graphing, I'm just going to graph everything. That does not make sense, okay? Some of these are not going to be nice to graph. You would have to do way too much work in order to be able to graph them. So that doesn't make sense, or it doesn't always make sense to do substitution or elimination, okay? It really makes sense. You got to look at your the tools that you have and what makes sense for what you're trying to do. Okay? All right, I hope this helps. Let me know if you have questions. Please try the rest of this worksheet.